Welcome back, everyone. So today we are going to do day 2, all right, what we started yesterday. So this is the same file, all right, just on the bottom of yesterday's notes. So hopefully this will be quick. We've only got 4 questions here. So we're going to start out with 2 proportion questions, all right. So proportions. The reason we made this its own day is because, just like we talked about yesterday, we know that everyone hates fractions, right? And this time we've got 2 fractions. And what do we do here? So when it comes to solving proportions, all right, just like we talked about before, when you have a fraction, okay, you want to get rid of what is on the bottom, right? And the way that you get rid of what's on the bottom is to multiply by that. So think about if we multiplied both sides by 3 here, all right? We multiply both sides by 3, okay? What happens? This cancels out, and since the 3 is on top, the 3 gets multiplied by the 2, right? We want to do the same thing with the x plus 4. So think about if we multiply both sides by x plus 4, right? These cancel out, and the x plus 4 multiplies by the 5. So you guys might have heard this term before, cross multiply. That's essentially what you are doing here. I just kind of wanted to explain what cross multiplication is. So cross multiplication is multiplying both sides by your 2 denominators. So this denominator here ends up being multiplied by the top over there. This denominator here ends up being multiplied across up there. So we're going to multiply these 2 things together. So we've got 3 times 2, that makes 6. And then we've got 5 times x plus 4. Now remember, all right, the way that this should look is it should look like this, 5 times x plus 4. Because you're not just multiplying the 5 by the x, you're multiplying it by the 4 as well. So you have to end up distributing here. So make sure you always keep that in mind. So that'll give us 5x plus 20. And so that's pretty much how you solve a proportion, okay? You cross multiply, and then now we just solve. So subtract 20 on both sides. That gives you negative 14 equals 5x. And then you divide by 5, and you get your answer. So this is going to be a decimal. So we have x equals 14 divided by 5. That's 2.8. So x equals negative 2.8. All right? And that's how you solve this. Now, I want you to remember when solving a proportion, that's the only time you cross multiply. All right? When you have 2 ratios that are equal. All right? Sometimes people will just see fractions and just start multiplying diagonally. It only applies in this situation, so just always keep that in mind. All right, so we're going to go ahead and look at another one here. This one's a little bit more complex, but we're essentially going to do the same thing. So we've got 5x minus 9, and we're going to multiply that by 8. So just like we did on part A, okay, we're going to need to distribute. So we've got 8 times 5x, that's 40x, and then 8 times 9, that's 72. Then we do the same thing over here. All right, 2x times 10 is 20x. Negative 8 times 10 is negative 80. So now we have gotten rid of our ratios. We've gotten rid of our fractions. We just have a normal equation to solve. And so we want to solve this. So we notice we have 2 x's here, right? We have 40x and we have 20x. So if you remember what I said yesterday, all right, we always want to get rid of the smaller x. So that would be the minus 20x. In this case, 20 is less than 40. If you're subtracting a bigger number by a smaller number, your answer will always be positive. So 40 minus 20 is 20. And now we can start getting x by itself. So we're going to add 72 to both sides. That gives us 20x equals -8. Now we divide by 20. This is going to be another decimal. So our final answer is what is going on? Sorry. Our final answer is 8 divided by 20, so -0.4. All right, so the extra x, it gave us a little bit extra step in our solving, but it didn't change fundamentally how we do the problem. So on your guys' practice problems, all right, when you have to solve proportions, you'll just do it exactly as we did here, okay? So the last thing that we're going to talk about some special cases, all right? So these aren't special cases in how the problem looks, all right? It's what happens when you start solving the problem. So when we look at this problem right here, it looks like a normal problem. We're just going to start solving and see what happens. So we notice that we have some parentheses there, right? So the first thing that we want to do, we want to get rid of those parentheses. So we're going to go ahead and distribute that -3. So this stays the same. So we've got -3 times x, that's -3x. And then we've got -3 times -5. A negative times a negative is a positive. So that's going to give us +15. All right, now we want to start combining like terms. So again, this side is going to stay the same. We have 11 minus 3x, that's 8x, plus 15. So we've combined like terms. Now we have our x's on both sides. Now we want to subtract the smaller x. And maybe you guys have noticed what is going to happen now. We have the same x on both sides, right? We have 8x and 8x. So one of them isn't smaller than the other. So subtracting 8x on both sides does what? All right. Well, 8 minus 8 is 0. So this cancels out and this cancels out. And what are we left with? Well, we're left with 40 on this side, and we're left with 15 on this side. So this is why this is a special case, okay? Your x's canceled out, right? And we're left with 40 equals 15. Now, there's two things that can happen here, all right? For this problem, does 40 equal 15? No, right? 40 does not equal 15. That is not a true statement. Therefore, this problem has no solutions, all right? It does not matter what number you plug in for x, you're never going to be able to get both sides the same. And that's because your x's will always end up canceling out with each other, leaving two unequal numbers on both sides. So no solutions, all right? 40 does not equal 15. So you probably can guess what's going to happen here. But we're going to go ahead, we're going to do it anyway. Now this is not a fun problem, all right? We got a bunch of fractions, but what can we do here to deal with these fractions, right? Well, one thing that we should notice is our coefficient here is 1/8, all right? So we want to think about, all right, what can we do here to get rid of that 1/8? Well, remember, to get rid of a fraction as a coefficient, you want to multiply by the reciprocal. So the reciprocal of 1/8 is just 8, because 8 over 1 is just 8. So we're going to multiply by 8, and that also means we're going to multiply this side by 8. Okay, so what happens here is that 1/8 times 8 is 1, so that goes away. So we get left with 6x minus 56. And now we want to distribute here. So we have 8 times 3/4, all right? So again, that's 8 over 1, so we can multiply straight across. 8, 16, 24, so 8 times 3 is 24 over 4. And then we have 8 times -7, that's -56. Forgot my x, all right? Now, why did I want to multiply by 8 here? Well, look at this fraction, all right? 24 over 4. 24 is divisible by 4, right? So that's a whole number. So what we can do here, all right, 24 divided by 4, that's just 6, all right? So now we have all whole numbers. So the reason that was the case is because, again, this is similar to what we talked about yesterday. 4 goes into 8, right? If we look at this just here, right, 8 over 4 is 2. 2 times 3 is 6. So this was a nice problem because that gave us all whole numbers. So what do we notice now? All right, this is our second special case. 6x minus 56 equals 6x minus 56. So if we did what we did last time, if we subtract our 6x on both sides to cancel out both of our x's, because 6 minus 6 is 0, 6 minus 6 is 0, what we're left with is negative 56 equals negative 56. So this is different than part C. Part C, we got two different numbers. Here we get the same numbers. All right, this is true. So here we'd say there are infinite solutions. All right. It doesn't matter what you plug in. For every number you plug in, you're going to get both sides the same. So there are infinite solutions. The other thing you could say here, you could say all real numbers. All right. That's another way that people have taught this. And this way is a little bit easier because you can use the symbol for the real numbers. I don't know if you know this, but the symbol for the real numbers is an R, kind of written like that with 2 lines. So you could just say, all real numbers, and that would be your answer instead of writing out infinite solutions. So any 3 of these things would work here for this special case. So these are the 2 things that could happen. So you are going to have a couple questions on your practice that are like this. So this is it for the notes today. All right. Hopefully this was short and sweet. Get any questions that you have. All right. Be prepared to ask them in the beginning of the Zoom session. I'll go over anything that you guys need, and then we'll start working on the same packet that we did in class today. Other than that, have a great day.